Hello, my name is Neelab Krishna. I am here to present the task 1 given by the Sparks Foundation internship program. I am from the April 2024 batch. The task 1 belongs to a simple linear regression task. In this, the objective of the task is to predict the percentage of marks that a student is expected to score based upon the number of hours they studied. This is a simple linear regression task as it involves just two variables. The independent variable is the number of hours studied and the dependent variable is the score achieved by the student. So for that, we need to import some important Python libraries. I have imported NumPy and Pandas. Importing NumPy as NP and import Pandas as PD. NumPy is basically a numerical computation library used to perform numerical calculation such as multiplication, addition on NumPy arrays. Pandas is used to basically read the CSV, Excel and other kind of files on the data frame. And after that, I imported matplotlib.pyplot as PLT. This is basically a Python visualization library. It used to make beautiful and meaningful charts in the Jupyter notebook and some other IDs. After that, I have written %matplotlib space inline. This code is written to basically preview the chart on the same page of the Jupyter notebook. If I remove this one, then after giving the plot command, the chart will be displayed in another window. After that, I have imported Seaborn as an Seaborn is basically it is also an Python visualization library built on top of Matplotlib. The use of Seaborn is that it requires less lines of code as compared to Matplotlib. So here I am reading the dataset from the URL given in the task. So the URL is this one. I have imported pandas as PD. So pd.read underscore CSV. It's basically a CSV file in the URL. So after that, reading and then saving the content in the DF data frame. And after that, displaying this data frame. This is the hours studied, the scores achieved by the student. Now I need to visualize the data set here. So plotting the data points on 2D graph to get the idea of relationship between the variables. So for that, I've used a plt.plot method. So df hours, uh, the hours column on the x-axis and the scores column on the y-axis. Basically, we are plotting at 2D graph. So here each data point is presented as a circle here. Then I written plt.x label to display the x label here, hours studied, and plt.y label, percentage of marks achieved. After that, I have written plt.title. The title of this 2D graph, percentage score versus hours studied, and plt.show to display this chart here. From this chart, we can find that there is a positive relationship between the two variables. Now we are preparing the data for further analysis. So x is taken as independent variable, y is taken as dependent variable. Is the score is dependent on the numbers of hours studied. I have taken dot values to convert the data frame into a NumPy array here. After that, splitting the data into train test and test data and train data using scikit-learn's train test split method. So for that, we need to import the scikit-learn's sklearn model, sklearn.model selection, where I imported train test split. I have written train underscore test underscore split. This is the independent variable x. Y is the dependent variable. I have taken test size as 30% of the total data set, and train size is automatically got 70%. I have taken a random state to an arbitrary numerical value. The purpose of taking a random state here is that if I run the code multiple times, I will get the same result here. So after that, using tuple unpacking, I got the values of x train, x test, y train, and y test. After that, training the linear regression algorithm with training data set. So for importing linear regression, I used linear model of the scikit-learn's library and initialize it into an LR object here. LR.fit method represents we are training the model on the given data set. So here the data set for training is X train and Y train. So after running the code, I got an output training complete. So it means that the model got trained on the given data set. After that, plotting the regression line. So for that, this represents a simple straight line equation y equals to mx plus c. So line represents y here, line variable here. Lr dot coefficient dot x. This whole term represents slope of the line, and this whole term represents the intercept y-intercept here. X represents the independent variable. Line represents the dependent variable here. So here I have taken plt dot scatter x comma y. So I have plotted dot scatter plots here. After that, plt dot will x comma line. So I have plotted the line plot and the scatter plot on the same plot here, and plt dot show. This line represents the line of best fit, which passes so most of the data points here. So after that, making predictions. After training and plotting the line of best fit, I went to the making predictions here. So for that, I have first print X test data set. It's basically a 2D array, as I can see here. Then using X test, I want to predict the Y values here. So lr dot predict method X underscore test gives Y pred values. Now comparing the actual versus predictor to find the accuracy of our model or to find the error term here. So for my convenience, I have taken pd.data frame here. I have created data frame was the first column is actual, y test dot reshape. The value of the actual column is y test dot reshape minus 1. So I have taken reshape minus 1 because I want to reduce the dimensionality of the array from 2D to 1D here. The purpose of dimensionality reduction of the array is to make it into a column of data frame here. Another column I have taken predicted. So I have performed the same operation on the y underscore pred value here. After that, predicting score when a student studied for 9.25 hours per day. So here is the question given in the task. I have to find what would be the score of the student who studied 9.25 hours per day. For that, I have taken hours as a variable here, np.array, putting the x value here, the independent value 9.25, and then perform the reshape function. So that 2D array got converted into 1D here. So after that, pred score using dot predict method, I predicted the what would be the score of that student who studied 9.25 hours per day. So using print function, I found that if a student studied 9.25 hours per day, he got a score of 96.54 out of 100. Now after that, evaluating the performance of the model. So for that linear regression model, I have used the mean of the residual method. The objective of this residual method is that it should be close to 0. So residual is basically an error term here, how much error we are getting or what would be the accuracy here. So y test minus y pred. Y test is the y value of the testing data set, and y pred is evaluated here. I evaluated right now here using the x testing data. So making the difference and taking the mean, numpy dot mean here, residuals. I am getting minus 1.26 here. So it's basically close to 0. It means that the model is performing well. Uh, for uh, for more uh, uh, for more analysis, I have done some distribution plot. I have plotted distribution plot here of the residuals. SNS represents the CBOL library here. This plot is in the distribution plot of the residuals, mean of the residuals here. Sorry, the residuals here. Then plt dot slope. So I am getting a more or less a normalized chart here, normal distribution here. So the mean of the residual is close to 0, therefore the model is working well. So that's it for this task. Thank you very much.